Good morning, everyone. Welcome to your 9.1 notes on quadratic graphs and their properties. By the end of the day, you will be able to graph quadratic functions in the form y equals ax squared and y equals ax squared plus c. So a quadratic function is one that looks like this. It can be written in the form y equals ax squared plus bx plus c. Quadratic functions include y equals 8x squared, or y equals x squared plus 4, or y equals x squared, or y equals 2x squared minus 9x plus 5. This one right here, y equals x squared, is a special one. We call him the parent function. He's a parent function because he's the most simple one. There's no funny business, there's no coefficients, just y equals x squared. He is the parent function because he's the simplest. So when we graph a quadratic function, it has a special shape called a parabola. You'll see this parabola right here. It looks kind of like a U. It's this U shape. So remember, a parabola is shaped like a U. It's U-shaped. Now, every parabola has a line that divides it in half, and these halves will match. They're symmetrical because they're measured the same. So we call this line the axis of symmetry. The axis of symmetry is the line, this line right here, that divides the parabola into two equal halves. It's called symmetry because symmetry means same, sim meaning same, and metry meaning measure. Just like a thermometer measures temperature, symmetry is measuring the same. So the point where the parabola crosses its axis of symmetry is going to be this point right here. We call that point the vertex. I like to remember vertex is the point, like at the bottom in this case, just like a V has a little point right there. The vertex is that point. Now, the vertex, actually, go ahead and pause the video and tell someone near you, what does a parabola look like? And include where is its axis of symmetry and where is its vertex. Now, a little point, to remember about your vertex is that the vertex will either be the maximum value or it will be the minimum value. What I mean by that is the vertex is either the highest point in your parabola or it is the lowest point in your parabola. In my example right here, this point is the minimum because it is the lowest the parabola will ever go. This is the lowest one. We can describe the shape of a parabola by saying which way it opens. We say that this parabola opens up because it can hold stuff. It's like a cup and it opens up. If a parabola opens up, then it's going to have a minimum value. And then if it doesn't open up, if it looks like this, then we say it opens down. If it opens down, then its vertex is going to be right there, and that is its highest point. So I have three graphs here, and let's identify where the vertex is. And we're going to say what its coordinates are and whether it's a minimum or it's a maximum. So on this guy right here, we have a vertex right here, and that is the point 3, 1. We say that is a minimum, and we can spell it right and everything. Minimum. Because that is the lowest point on our parabola. Now B, our vertex, is down here. This is at the point 1, -6, and this is also a minimum. On graph C, our vertex is right here. That is at the point -3, -1, and this one is a maximum. It's a maximum because that is the highest point on our graph. These two parabolas right here open up. They open up because they face up. It's like they're a cup that can hold something. This parabola opens down. Oops. Opens down. Now you'll remember from previous lessons that the domain of a function is all the domain of a function is all the x values it can cover, and the range is all the y values your function covers. So how we graph a parabola is we're going to make a table of values. We're going to make an xy chart, and then our x points will tell us our domain, and our y points will tell us our range. So let's go ahead and pick some points, pick some x values, see what y values they give us. So for our first graph, we have y equals x. Y equals x squared. You remember that this is called the parent function. It's the simplest, most basic quadratic function. So let's see what happens when x is -3, -2, -1, 0, 1, 2, and 3. Well, -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now that we have our x, y points, let's go ahead and plot them. So you have over -3, up 9, over -2, up 4, over -1, up 1, 0, 0, 1, 1, 2, 4, 3, 9. Now if we connect these, hopefully we'll see a U shape. And we do. I missed a little bit, but that's okay. There we go. There's a parabola. Excellent. You'll notice that the vertex is here at 0, 0. 0, 0 is our vertex. And our axis of symmetry is right here at x equals 0. So that was our first function. Now we're going to see what happens when we adjust our function just a little bit. For next one, we're going to make another xy chart. Our function is y equals x squared plus 3. Oh, we didn't identify the domain and range. Whoops. So our domain, here's all the x's. Now we can plug any x in here and it will make sense. So we'll say our domain is all real numbers. I didn't really leave a space for this, did I? Domain is all reals. And our range is limited. You'll notice that our graph never goes below the x-axis. That means we will never ever get a negative value for y. So our y is greater than or equal to 0. So don't forget, going to write that here. Domain and range. Okay, let's make another XY chart on our next graph. So remember, our domain is going to be all of our X values, and our Y is going to be all of our range is going to be all of our Y values. Let's plug in those same numbers, -3, -2, -1, 0, 1, 2, and 3. So to find out what our Y is, we plug in -3 for X. -3 squared plus 3 is 9 plus 3, which is 12. -2 squared plus 3 is 4 plus 3, which is 7. -1 squared plus 3 is 1 plus 3, which is 4. 0 squared plus 3 is 3. 1 squared plus 3 is 4. 2 squared plus 3 is 7. And 3 squared plus 3 is 12. So let's go ahead and plug those points on our graph. So we have -3 up 12, -2 up 7, -1 up 4, 0, 3, 1, 4, 2, 7, 3, 12. And we connect our points. Our vertex is here at 0, 3. And our axis of symmetry is still at x equals 0. Now our domain for this function is all reals. That means you can plug in any number for x and you'll still get an answer out. Our range, however, is limited. You'll notice our y never goes below 3. So y is greater than or equal to 3. Now if we did this right, you should be noticing a similarity between our graphs so far. You'll notice that between y equals x squared and y equals x squared plus 3, it's the same graph, we just shifted it up by 3. Did you miss that? I'm going to do it again. So to go from y equals x squared to y equals x squared plus 3, it's that exact same graph. All we did was move it up 1, 2, 3. Isn't that crazy? That's nuts. Now let's see what happens when we have a similar graph again, but there's something a little bit different. We've got that 2x squared right there. Again, to graph it, we are going to make an xy chart. So you have x, and to find y, we do 2x squared plus 3, which will give us our y. We'll also want to remember to identify both the domain and range of our function, given by our domain is our x values and our range is our y values. So let's use that same set, -3, -2, -1, 0, 1, 2, and 3. Now 2 times -3 squared plus 3 is 2 times 9 plus 3, which is 18 plus 3, which is 21. And then 2 times -2 squared plus 3 is 2 times 4 plus 3, which is 8 plus 3, which is 11. 2 times -1 squared plus 3 is 2 times 1 plus 3, which is 5. 2 times 0 squared plus 3 comes out to 3. 2 times 1 squared plus 3 is 5. 2 times 2 squared plus 3 is 11. And finally, 2 times 3 squared plus 3 is 21. Now on this function, we can plug in any number into our x and still get a value. So our domain again is all real numbers. And here our range, you'll see that it goes down to 3 and then goes up again. So our y is always greater than or equal to 3. Let's go ahead and graph our points. So we have -3 up 21. Oh, that's too far. That won't fit on my graph. Oh well. -2 up 11. -1, 5, 0, 3, 1, 5, 2, 11, and 3, 21. Again, that's off my graph, so that's not going to work. Let's go ahead and connect our points. We should get a nice U shape on our parabola. Mine's a little special, but that's okay. We'll see our vertex is still at 0, 3 like last time. And our axis of symmetry is the same as last time. It's still at x equals 0. Now our axis of symmetry, remember, means that this side looks the same as this side. And they do. Now our graph looks a little bit different than our other ones. It's got the same y-axis. This is because we have a +3 and a +3. However, what happened to this graph here? Compared to our other two, this guy's a little bit skinnier. So he looks the same as our second graph, except he's trimmed down a little bit. He's squeezed. He's skinnier. So that's what happens when we have something in front of our x squared. So you'll notice from our patterns here, when we started with our parent function, y equals x squared, but then we added a number to that, y equals x squared plus 3, that moved our graph up 3. So C represents a shift up. That means it goes up. In our third graph, we had y equals 2x squared plus 3. So not only did we take our graph and move it up 3, but we also squeezed the graph. So A will change the width of the graph. You can see this happen in real time using the graphing calculator on Desmos. So here on Desmos, I have graphed for you y equals ax squared plus c. And notice what happens when I change my a. When I change a and I drag it over to make it bigger, my graph gets skinnier. Because as a gets bigger, the graph squeezes and gets skinnier. However, as a goes back down, the graph gets wider. So if a is small, the graph is wide. Whoa. But what happens when it's negative? That will flip our parabola upside down. And then again, the more negative it gets, the skinnier it gets. So as a gets smaller, well, as the absolute value of a gets smaller, it gets wider. If a is bigger, it's skinnier. And if it's negative, you flip it upside down. Now what happens when we change c? When we change c, as c goes up, our graph shifts up. As c goes down, our graph moves down. I've posted this link for you guys, and you can play around with it on your own time. In fact, you can set this to just play automatically, and it will move all by itself. Isn't that great? So fun. I love math. Well, I hope you guys have a great time exploring parabolas, exploring the properties of parabolas with your graphs. Remember, this is your key idea. If you have a quadratic function in the form y equals ax squared plus c, then a will change how wide your graph is, and c will change your y-intercept. Your y-intercept. It'll move your graph up. I hope you enjoy your homework.